Ocean acidification is a serious environmental issue caused by the absorption of carbon dioxide, CO2, from the atmosphere into seawater, leading to a decrease in ocean pH. This process alters the chemical composition of the oceans, affecting marine ecosystems and organisms, including shell-forming organisms like corals and mollusks. Here are 10 regions known for their vulnerability to ocean acidification and its potential impacts. Coral reefs. Coral reefs are particularly vulnerable to ocean acidification. As ocean pH decreases, it becomes more difficult for corals to build and maintain their calcium carbonate skeletons, which are essential for reef structure. Acidification weakens corals, making them more susceptible to other threats like coral bleaching and disease. Polar regions. Polar oceans are experiencing more rapid acidification due to their lower temperatures, which makes it easier for CO2 to dissolve in the water. Acidification poses a threat to the unique marine life in polar regions, including krill, plankton, and fish, which form the basis of the polar food web. Upwelling zones. Upwelling zones are areas where nutrient-rich waters from the deep ocean rise to the surface. These areas often have low pH due to the natural release of CO2 from deep waters. Ocean acidification in upwelling zones can have significant impacts on the marine ecosystems, affecting fisheries and biodiversity. Eastern boundary currents. Eastern boundary currents, such as the California Current and the Humboldt Current, are areas where cold, nutrient-rich waters upwell along the eastern margins of ocean basins. These regions are highly productive and support diverse marine life, but they are also susceptible to ocean acidification, which can disrupt the food web and fisheries. Deep-sea ecosystems. Deep-sea ecosystems, including cold-water corals and deep-sea organisms, are at risk from ocean acidification. The deep ocean acts as a sink for atmospheric CO2, making it more susceptible to acidification. Changes in these ecosystems can have cascading effects on marine biodiversity. Coastal zones. Coastal zones, where land-based pollution and runoffs enter the oceans, are at risk of local acidification due to increased CO2 and nutrient inputs. Acidification in coastal waters can affect shellfish, marine plants, and other coastal species. Shellfish fisheries. Ocean acidification can negatively impact shell-forming organisms, such as oysters, clams, and mussels. Acidification reduces the availability of carbonate ions needed for shell formation, affecting shellfish growth and survival. Arctic Ocean. The Arctic Ocean is undergoing rapid acidification due to its cold temperatures and the uptake of CO2. This poses a threat to Arctic marine life, including fish, marine mammals, and invertebrates. North Atlantic. The North Atlantic is also experiencing ocean acidification due to the absorption of CO2 from the atmosphere. Acidification can affect the distribution and abundance of marine species, including fish and plankton. Equatorial Pacific. The Equatorial Pacific Ocean, a biologically diverse region, is susceptible to acidification due to its warm surface waters and upwelling of CO2-rich deep waters. Changes in pH can disrupt the delicate balance of this ecosystem. The impacts of ocean acidification are far-reaching and threaten the health and resilience of marine ecosystems worldwide. Acidification can disrupt marine food webs, alter species distributions, and reduce the ability of marine organisms to build and maintain their shells and skeletons. Moreover, the potential loss of coral reefs and other vital habitats could have severe consequences for coastal communities that depend on marine resources for food, livelihoods, and cultural practices. Addressing ocean acidification requires reducing CO2 emissions globally and enhancing the resilience of marine ecosystems. Efforts to mitigate acidification include transitioning to renewable energy sources, improving coastal management practices, protecting marine habitats, and implementing sustainable fisheries management. International cooperation and coordinated actions are essential to safeguarding the health and biodiversity of our oceans for future generations.